Okay. Type, that would be really cool. So we are going to get started on Unit 10, Day 2 notes today. These are in OMHS. On Monday, you should have done a play posit for Unit 10, Day 1 notes. And so there was an exit ticket and an attendance quiz and all of that in there. I'm going to go through today's notes, and then at the very end, I will give you some updates on the benchmark and some of these other questions that are coming through. But let's go through the notes first, and then at the very end, I will talk about the benchmark and the end of the quarter and all of that fun stuff. Okay, wonderful. So we are in Unit 10 talking about circles. So if you asked me how I was and I told you my head was going in circles, that's why. Lots of circles today. It's kind of fun working in a different shape, though, I think, especially when we've been working in triangles so much. In the play posit on Monday, I included a link to the PDF, and I also referenced it on OMHS. There is a document in OMHS called Parts of Circles Definitions, and I have all of these different parts of circles that I'm hoping that you have heard at some point before. If you haven't, then you are welcome to check out the definitions and see what they say. I'm also going to kind of go over them briefly as we see them in the notes. Okay, so we're talking about chords and arcs here. A chord is a segment, and it's a segment whose endpoints are on the circle. Okay. All right. Just FYI, if you're asking me questions about the benchmark or any of that kind of stuff, I'll answer them at the end. So just ask me again there at the end if I don't cover it. All right, so a chord has its endpoints on the circle, and it goes through the circle. So AB is a chord. CD is also a chord because it's a segment whose endpoints are on the circle. Wonderful. An arc is a piece of the circumference. So remember, the circumference is the length around a circle. An arc is a piece of that. So I can say that arc AB is a piece of the outside part of the circle. There's lots of arcs in this picture. HB is an arc, AH is an arc, CD is an arc, CI is an arc. There's lots of arcs in this picture. It's just a piece of that circumference. Okay, now arcs are measured in two ways. You can have the measure of an arc, and when I'm talking about the measure of an arc, I'm talking about how many degrees are in that arc. And then arcs also have length. Okay, so the length of an arc is if I were to cut it off of the circle and stretch it out straight and measure it. Okay, so if I'm talking about the measure of an arc, I'm talking about the degrees. And if I'm talking about the length, I'm talking about how long is it? Okay, so today we're going to talk about if those two chords are congruent. So if AB is congruent to CD, what happens? Okay, well, the two chords will be congruent if and only if their corresponding arcs are congruent. Okay, so let me write that and then I'll talk about it a little more. Their corresponding arcs are congruent. Okay, so in this picture, AB will equal CD. Those chords will be equal if and only if the measure of arc AB is equal to the measure of arc CD. Okay, and remember way back in Unit 2 when we talked about biconditional? There is a word we haven't heard in a while. Biconditional, that if and only if sentence. That means that it will work forwards and backwards. So I could say the chords are congruent if their arcs are congruent, and I could say it the other way. The arcs inside are congruent if the chords are congruent. So it works both ways. Another definition with our two congruent chords says that the two chords are congruent if and only if they are equidistant to the center. I'll talk about that in just a second. Equidistant the center. All right, so equidistant meaning equal distance. So if the distance between the center of the circle and chord AB is equal to the distance from the center of the circle to chord CD, then those chords will be congruent. Okay. So chord AB will equal chord CD as long as their distances to the center is the same. So FE is equal to GE. Now, if you have a diameter or a radius that is perpendicular to the chord, okay? Perpendicular, of course, means it intersects it at a 90-degree angle. It's a U, perpendicular to a chord. Then it bisects the chord. Oh, there's a word we haven't heard in a while. Bisect means cut in half. So it bisects the chord, and it bisects its arc. Okay, so what that means here is you have this radius. Here we have radius EH. See it there? And it's perpendicular to AB. So EH is perpendicular to AB. If that's true, then AB is being cut in half. So FA will have to be congruent to FB. And if the chord is being cut in half, then the arc inside of it is also being cut in half. So the measure of arc AH will be equal to the measure of arc BH. Okay, so the name of the game here is, are they equal or are they being cut in half? Okay. And I like it in this picture because it's very visual. Right? Like if it looks equal, it probably is. If it's being cut in half, it probably looks like it's being cut in half. The picture is not going to be tricky. All right, so let's look at some examples that use this information. All right, so here we go. We've got a circle, and we've got two chords in that circle. I have chord SR and chord ST. And I know those chords are congruent because they're marked there with the little tick marks. And so if those chords are congruent, that means that the arcs inside of them are congruent. Yep, so we can say, oh, well, 115 has to be equal to 7x plus 24. Cool, well, that was the geometry part of this problem. Yeah, Rachel, you got it. Now we play algebra. Subtract 24 from both sides. Divide by 7. Cool. Good job, Rachel. Yay. And it was just asking us for x, so we're done. We have x equals 13. So now the converse of that rule works too. So if the chords are congruent, the arcs are congruent. Well, over here, number 2, if the arcs are congruent, then those chords are congruent. Okay, so there's your converse. So I can say, oh, well, 52 equals 18x minus 2. Okay, how did I know those arcs were congruent? They had little tick marks on them, and that's what that means. So now we solve for x. Add 2 to both sides. Divide by 18. 3. It doesn't matter if it's on the line or on the curve. So the tick mark, is that what you mean? Yeah. So if the tick mark is on the curve, then that means that curve is congruent to the other curve. When we say curve, we mean arc. And then if the tick mark is on the line, like over here, number 1, then it means that those chords are congruent. Oh, it's okay. I knew what you meant. Ella, I don't think you missed a whole lot here. You could maybe watch like the first 10 minutes later. Yeah, you didn't miss a whole lot. You're all right. Okay, and Rachel is zooming ahead of me here. Got to catch up with Rachel. All right, let's look at number 3. Number 3 is tricky in the sense that it's not asking us for x, it's asking us for xy. So what we're going to do is we're going to solve for x, but then we got to make sure we answer the question. And we're going to take that x and we're going to plug it back in and find the length of our chord. All right, so I've got 2 chords, and the arcs that make them are labeled as congruent. So my red arcs are congruent, which means my blue chords are congruent. So I can say 9x minus 34 equals 4x plus 1. And now we solve for x. Subtract 4x from both sides. Oops, that's a positive one. Add 34 to both sides. You guys are faster than I am at this. Divide by 5. Wonderful. Guess you're not all writing on a screen for everyone though too, right? Yeah. All right, so if this was a multiple choice question, 7 would be there. Don't pick 7. 7's wrong. Why is 7 wrong? Because it wanted to know the length of xy. So we got to take that variable x and plug it back in. 4 times 7 plus 1, and it's 29. So on a multiple choice test, don't pick the 7, pick the 29. All right, I am going to let number 4 be for you. But before we move on, do you want to just tell me in the chat, what would your equation look like for number 4? How would you start? What would your starting equation be for number 4? Yeah. Good job, Mohammed. You're right. Anyone else? Jalen and Rachel, you are rock stars. Moheen got it. Ooh, Katie used parentheses. Yep, very good. Anyone else? Alexis, you got it. Yay, I'm seeing a lot of good stuff. Haven't seen a wrong one yet. All right, so if you said some version of 5x plus 6 equals 11x minus 72, you are correct. Maybe you said 11x minus 72 equaled 5x plus 6. Same thing. Awesome. Okay, I'm going to let you solve that one and plug it in and find the measure of arc RS. I would like to move on so we can see some more examples. All right, number 5. Okay, I'm showing you as many examples as I can using the ideas. Please know that any problem you see on an assessment could look different. It's really not a good idea to memorize how I do each individual problem because each problem can look so different given whatever information is there. The best way to solve problems like this is to remember the relationships. And if you can remember the relationships, then you can solve any problem I throw at you. Let's see. When you say arc, it's the circumference part. When you say xy, it's the chord. Yes, so when I say arc, I'm talking about the curvy piece between the 2 points. And when I say just like xy or chord xy, I'm talking about the straight line between them. That was a really good question. All right, so in number 5, the relationship I see here says you've got congruent chords. Woohoo, congruent chords. Congruent chords tells me congruent arcs. All right, well, let's see. How could I solve for x? Well, I know my blue arcs are congruent. Ooh, Jalen, you're right. So I can say 6x minus 20 represents this blue arc. They're the same size, so they could have the same expression. But now if you don't write this, I'm going to write something wrong here. If you write this, there's nothing wrong with that. They are equal, but you're going to end up with 0 equals 0, and that's not going to help you solve for x. So there's got to be another way to solve. All right, here's the trick. What's the measure of a circle? Yeah, Moheen, you got it. Yeah, the measure of a circle is 360. So if I were to, spin in a circle, I've spun 360 degrees. Well, this green arc, 76, plus my 2 blue arcs will have to add up to 360. Cool. All right, well, now we solve for x. 6x plus 6x. 76 minus 20 again. What do we get? 36. Subtract 36 from both sides. Is that right? 324. And then divide both sides by 12. Yes, very good. And the question was just asking us for x, so we can stop right there. Oh, sorry, Mohammed, I was going fast. Cool. All right. Let's look at number 6. All right, number 6. The given information says that arc KJ is congruent to arc KL. Awesome. Well, we know that if the arcs are congruent, then the chords are congruent. And then we learned if the chords are congruent, then the distance from the chord to the center is congruent. Okay, so my blue lines are congruent, my green lines are congruent. How does that help me here? Well, it says that MP is 5x minus 32. Oh, that was right here. And PN, that's this guy, is 2x minus 4. How do we know the chords are congruent? So we know the chords are congruent because the arcs inside of them are. So my red line kind of hid that, but where's my eraser? So you see the little tick mark right there on the arcs? That tick mark means congruent. And so that since the arcs are congruent, that's proving that the chords are congruent. Nice. That was a really good question. Thank you for asking. So let me write this. All right, so since the arcs are congruent, the chords are congruent. And if the chords are congruent, they're equidistant to the center. So I can say that MP and PN have to be equal. All right, now we solve for x. Subtract 2x from both sides. Okay, don't forget that's a -4 right there. So if you subtract 2x from both sides, you're left with -4 there on the right. Add 34 to both sides. You're so bad. Let me try that again. And divide both sides by 3. Yeah, sorry for the little disruption there. I thought she was locked out of the room. Clearly not. Her name is Willow, but we call her Bad Cat. Oh, Rachel, I have no idea. I'll give her her little backstory at the end of class. How's that? Remind me. Ask me again at the end about her. All right, so we got x equals 10. On a multiple choice test, 10 would be there. Don't answer 10. Why? Because it's asking us for MP. So make sure you plug that in for MP. 5 times 10 minus 34. What do we get? 16. Thank you, Jalen. You're awesome. But you already knew that. All right, let's look at number 7. Number 7, it says DE is this expression and FG is that one. Okay, so DE is a chord and FG is a chord. And the distance from the chord to the center, those are equal. So if the distance from the chord to the center is equal, then the chords themselves are equal. So I can say that DE has to equal FG. Yep, Sybil, you got it. Good job. Oh, I'm going slower than you guys. Let me speed up a little, huh? Subtract 11x from both sides. What do we get? 21x. Add 27 to both sides. And divide by 21. So we get x equals 2. Yes. So now we got to take that DE and plug it in, or plug in the 2. 11 times 2 plus 15. 37. Very good. Thank you guys in the chat. You made me not have to use the calculator. Cool. Yep. You're right, Moheen. So the name of the game in this really is, are they equal or are they being cut in half? And that's pretty much it for your chords. All right, let's do number 8. Yeah, Katie, you got it. You're right. So MP is what we're looking for. But MP doesn't even have an expression. So let's figure out at least how to find X. So if you're ever not sure how to solve a question, but there's a bunch of expressions there with X, find X and then see if you can use that to find whatever they're asking for. Okay, so let's see. These chords are equidistant from the center. And if the chords are equidistant from the center, then their arcs are congruent. So I can say that 9x minus 43 equals 5x plus 33. Subtract 5x from both sides, or if you're just using Desmos to solve this, maybe that's how you guys are going so fast. 76, divide by 4, 19. Thank you. All right, so now we got to find MP. Well, we know X, so let's plug X in for each of our blue arcs. 5 times 19 plus 33 is 128. And 9 times 19 minus 43 is 128. Well, it makes sense that those are the same because they had to be congruent. All right, and there's a lot of you have figured this out already. The measure of a whole circle is 360. So when you add all of these arcs together, in this case, there's 3 of them, they have to add up to 360. And so, yeah, if you're saying the measure of arc MP is 104, you are correct. Good job. The measure of arc MP would be in degrees. Arcs, the measure of arcs, just like the measure of angles, are in degrees. The length of the arc would be in a unit, like inches or centimeters or something. But the measure, when I say the measure, I'm talking about how many degrees it is. Very good questions. On an assessment, I take care of that unit for you. So don't worry about typing the degree symbol in an assessment. I take care of the unit for you. Ooh, here's a good question. What's the difference between length and measure? Measure is how many degrees it is, and length is how long it is. So measure is in degrees. How many degrees is it? I just turned 90 degrees. That's a measure. Length is if I were to walk along that line, how far did I go? Okay. So arcs have measures, arcs have lengths. 360 is a measure that's in degrees, 360 degrees. That's the measure of a circle. The length of a circle is if you were to unwrap that circle and make it straight and measure it. We call that the circumference. Yeah. All right, let's look over here. Ooh, lots more examples. All right, number 9. It says in circle Z. Okay, we name a circle by its center. So I call this circle Z because the point in the middle is Z. Okay. In circle Z, RS equals 18. The measure of arc TY is 42 degrees. And we're going to find all these missing things. Okay, before we do that, let me give you your attendance quiz word. I don't want to forget. So your attendance word for today is measure. Okay, write that down, highlight it, circle it, whatever. Measure. Got it? Measure. Once I stop talking about it, I'm not going to come back. I can't come back and talk about it anymore. So make sure you write that down because I can't give it again. Oh. Rachel wants to do the hokey pokey like I usually say. Yeah, write it down, circle it, do the hokey pokey, and turn your chair around. All right. Correct. Yeah. All right. So that was your attendance word, measure. All right, here we go. Let's mark up this picture. We know that Z or RS is 18. So this whole chord is 18. And the measure of arc TY is 42. arc TY, meaning on the circle there, the curvy part, that's 42 degrees. Let's find all this other stuff. All right, well, I see in my picture that ZW is congruent to ZV. And so since ZW is congruent to ZV, that means that the chord RS is congruent to chord TU. So TU has to be 18, since RS is 18. Right, that's nice. Let's see. Also, we have these radii, ZX and ZY, and they are perpendicular to those chords, which means they're cutting the chords in half. So if the chord is 18 and I cut it in half, that means that each piece is 9 on each one because they were the same length. So does that help me with TV? It does. TV is 9. And it helps me with WS. WS is 9. All right, so now let's talk about the arcs. Because the chord TU is being cut in half, that also means that the arc inside of it is being cut in half. So arc TU is being cut in half, and I already know what half of it is. Half of it's 42. So if half of it's 42, the other half is 42. Okay, so does that help me out at all here? Yeah, YU, right? YU is 42. Yeah, Mackenzie, you're right. All right, well, since RS and TU are congruent, that means that each of these arcs are going to be congruent to what's down here. So each piece here is 42. And the question says, what's the measure of arc RS? Well, arc RS is this whole thing. 2 42s, 84. See why it's like a puzzle? You just got to figure out what size each piece is. Very nice. All right, number 10. In circle I, BG is 17. All right, so this piece right here is 17. Let's just deal with the lengths for a moment. So if BG is 17, and I see that EI is congruent to DI, then that means that chord BC is congruent to chord BA. They're both being cut in half since that radius is perpendicular to the chord. So if BG is 17, that means that GC is also 17, which means that BF is 17 and FA is 17. Cool. So now we could find BC. BC was cut in half. Half of it was 17. The other half was 17. So the whole thing together is 34. Very good. Let's see, can we find FB? Yeah, FB, we labeled it right there already as 17. Nice. So I'm going to erase all of my 17s here just so it doesn't get too incredibly messy. Now we can talk about the arcs. Okay. It says that arc CHA, just a little review on how to name an arc. You start at the C, follow the arc, the curvy part, to the next letter, which is H, follow it to the next letter, which is A. So this arc is 256 degrees, that whole piece. All right, well, we know that chord BA and chord BC are congruent, which means that arc BA and arc BC are congruent. I'm going to call them X, just because I don't know what they are, but they're the same thing. Yeah, but we know that the measure of a circle is 360. So we can say, oh, well, the 2X arcs plus the 256 arc, they all have to add up to 360. How do you not know what they are? Well, it doesn't tell us what the measure of those are. We have to figure that out. 34 is the length of chord BC. It's not the measure of the arc. This is a chord. This BC up here, this is the straight line between B and C, not the measure of the arc. Yeah, good question. Let's find the measure of each of these arcs X. So 2x plus 256 equals 360. Subtract 256 from both sides, which I already forget. Oh, I just had it. 360 minus 256, 104. Divide both sides by 2, 52. So the measure of arc BC is 52, which means the measure of arc AB is 52, and these are in degrees. So AB we just said was 52 degrees. Measure of arc BC is 52 degrees. And EC, well, EC is half of arc BC. So half of 52, 26. Nice. Rachel, you'll have to teach me how you're typing the degree symbol into the chat because that's pretty cool. The E got kind of hidden in my mess here. The E is right there, Moheen. There you go. Or Mohammed, sorry. Lots of M's coming through. All right, nice. All right, let's look at number 11. Ooh, I like this one. Okay, number 11, we have QM, and they're telling us that 6x minus 11. And then they're telling us MR, and they're telling us MR is 2x plus 9. All right, well, QM is part of this chord, LM, and MR is part of this chord, MN. Those two chords are equidistant from the center, so that means those two chords are equal. Yeah, and they're bisected. So just for a moment, let's talk about something slightly different. Okay? Let's say for lunch, I make my two children peanut butter and jelly sandwiches, and the bread came from the same loaf. So these sandwiches are exactly the same size. My daughter says, "Mommy, you need to cut my sandwich in half." So I cut her sandwich in half. She yells at me because she wanted triangles instead, but this is what she gets. My son says, "You need to cut my sandwich in half." So I cut his sandwich in half. And then because I'm a math teacher, I do this instead. I say, "Here, Reagan, you get this half, and you get this half. And Mason, you get this half, and this half." Did I give them a fair amount of sandwich? Yes or no? There's a poll on your screen. Was that fair? I gave Reagan the left halves and Mason the right halves. Did they get the same amount of food? Oh, if he said cut my bread diagonally. Ooh, I really like this thought. Okay, if you said yes, I agree with you, right? Reagan got 2 halves and Mason got 2 halves, and their halves were exactly the same size, so they got the same amount. Now, someone asked me a really good question, which doesn't really have to do with this, but I want to talk about it anyway because it's an awesome question. Oops. Okay, here is the other sandwich. Okay, and we have to pretend that they're cut in half because, well, I'm not the best at drawing. Oh, what am I doing? Enzo asked me, what if you cut it diagonally? What if I cut his in triangles instead? Did they get the same amount? Think about that. Did they get the same amount? If you have an argument for your reason, go ahead and type it in the chat. I'm really enjoying watching what you guys are writing there. I didn't cut the crust off. They're exactly the same sizes. I cut one in half. I gave one half to my son, one half to my daughter. I cut the other one in half. I gave one half to my son, one half to my daughter. Awesome. All right, let me read some of these responses I got in the chat because you guys are brilliant. Okay, so here we go. There was the question. Okay, so we say they're the same size because they each got half of each, right? Reagan got half of the first one and half of the second one, and Mason got half of the first one and half of the second one. So even though they're the two pieces they got were different shapes, they still each got half total. Okay? If you were to put the diagonal piece on the rectangle, it would be bigger than the one with the two rectangle halves. Oh, but if you think about how much sandwich they got, right? Like, all right, pretending I can draw pretty. Reagan got a rectangle and a triangle. And Mason got a rectangle and a triangle. So they each got a rectangle and a triangle. So they got the same amount. Okay. All right. Kind of went off task a little bit there. But the idea is if I cut two things that are exactly the same in half, then their halves are all going to be equal, which I kind of went off a little bit there. But if I have two things that are exactly the same size and I cut each of them in half, now I have 4 equal parts. Okay. All of that to just say, let me get rid of all this stuff. Hold on one second. All right. Beautiful pictures of sandwiches. Okay, so I have segment ML. Here it is. Just like the sandwich, I cut it in half. There's one half. There's the other half. Cut it in half. That means those two pieces are the same size. Then I have another segment, MN. I cut it in half, just like the other sandwich. And if I cut it in half, that means these two parts are congruent. And ML was congruent to MN at the beginning. So I've got now 4 equal parts. So that tells me that MQ has to be equal to MR. Or QM, right? Because that's what they called it here. We'll call it QM to stay consistent. So I can say that 6x minus 11 equals 2x plus 9. Hopefully my sandwiches didn't confuse you. I was hoping that it helped. But if you have two things that are exactly the same size and you cut them in half, then you have 4 equal parts and you can mix and match them however you want. Subtract 2x from both sides. Add an 11. I've now run out of space. Divide by 4. And make sure that you answer the question. Find MN. Okay. Well, now we have to say, oh, well, MN is this whole thing. So if I plug in 5 for MR, 2 times 5 plus 9, that tells me that half is 19, which means the other half is 19. So the whole thing, my final answer, MN equals 19 times 2, or 19 plus 19, 38. All right, I'm not going to go through all of number 12, but I do want to just kind of talk about the relationships that we see in that circle. Okay, and I'm going to start you off. If I said chord CD, that's the straight segment between C and D, what would that be equal to? What other segment would CD be congruent to in this picture? Yeah, EF. Awesome. Okay, now what if I talked about the arcs instead? So the arc, the measure of arc CD, that's here. That's not the straight line, but that's the curvy part, right? What arc is that congruent to? Yeah, it's still EF. Except this time it's a chord, right? Or an arc. The curvy part. Very nice. What if I said CI? I want arc CI. What is arc CI congruent to? There's more than one answer for this. Ooh, FJ, good. What else? Oh, Zoran got them all. EJ, And one more, ID. Yay, awesome. Just knowing those relationships can help you figure out how to set up your equations. What's equal here, or what's being cut in half? Okay, so let's go to the last page of the notes, which I've been so excited for this whole time. All right, Unit 8 is going to come back to haunt us. I don't know, haunt us, is that the right word? I'm very excited because we're going to have to use some stuff from Unit 8. Okay, you'll see what I mean in a second. Here we have a circle with a beautiful chord and a radius. And number 13 says, find VW. Okay, that's a length. So I'm looking for the length of the chord. Rachel, you got it. What if I found ZW? If I know ZW, then I could just multiply it by 2 and get the whole thing. Look at my beautiful right triangle. There it is. We know this leg is 5. We know that hypotenuse is 13. And I'm going to call ZW X. Yep. Beautiful right triangle. We've got 2 sides. We're missing a third. So that means our friend Pythagoras is going to be helpful here. Yeah. Ooh, Alexis, you even spelled it right. Good job. I think you might be the first one today. All right. So C, of course, is always the hypotenuse. So that's 13. A and B, the legs. And so now we just play Pythagorean theorem, right? Algebra. 13 squared. 5 squared. I need that x squared by itself. So we subtract 25 from both sides. Zoran, you got it. And then to undo a square, our friend, the square root. Square root of 144 is 12. Now our answer is not 12. We do have to be very careful. ZW is 12. So that means that VZ is 12. So our final answer to answer the question, VW, 24. Yes. Very nice. All right. So that was our friend Pythagoras. Let's look at number 14. I'm going to erase my mess that I have here just so we can see what's going on. Okay. So arc, the measure of arc YW. Here it is. In the Play Pause It on Monday, we learned that the measure of the arc is equal to the measure of the central angle that makes it. So here's the central angle. Okay. Its vertex is the center. If I can figure out the measure of this angle, then I will know the measure of that arc. So I'm just going to write this down here. The measure of angle YXW, that central angle, will equal the measure of arc YW, the arc inside of it. So looking back at that right triangle, because he's still going to be helpful here, I'm going to redraw it. We know the hypotenuse is 13, the leg is 5. That angle that I just marked, that blue angle, is right here between the 5 and the 13. So we're going to use our pal SOHCAHTOA. Yep. So we have our angle, let's call it Y, just so we have a variable. The hypotenuse is 13, and the leg that's touching it, we call that the adjacent. So I have an adjacent and a hypotenuse. Cosine. Cosine of the angle equals a fraction. The angle was Y. The fraction is adjacent over hypotenuse, 5 over 13. Uh-oh, the variable's stuck in the parentheses. Yeah, Mohin, you got it. Let's see, I haven't really been looking at the chat. How do I free the variable from the parentheses? What can I do? Inverse. Yes, great vocabulary. I love it. So remember, we learned that if your variable is in the parentheses, you can flip-flop or invert your variable and your fraction as long as you make it an inverse. So in your calculator, in degree mode, we're going to find cosine inverse of 5 over 13. And we get 67.4. Okay. All right, so my angle is 67.4. Going back to the bigger picture over here, because we're really talking about this circle. Okay, if that angle is 67.4, That means the measure of the arc inside of it is equal to that. So we can say the measure of arc YW is 67.4 degrees. Very nice. All right, looking at number 15, new picture this time. Number 15 says find pH. That's here in the picture. Well, it says that HK is 30. That's here. PM is 8. Oh, well, the picture is telling me that PM is congruent to PN. And we know that this is, I hit it kind of with my pen, but there's a right angle there. So I'm looking at a right triangle. Here it is. All right, here's that right triangle, a little bigger. We know this is 8. There's your right angle. We're looking for pH, so let's call that X. What's the length of this leg? Oh, what's the length of HN? 15. Very good. They told us that HK was 30. And so since it's being cut in half, this piece right here, this leg is 15. Very good. Yep, Pythagoras is coming back to play. You know, I wanted to name my hamster, or not my hamster, my guinea pig Pythagoras. My husband wouldn't let me. That was a long time ago. All right, so we know that the hypotenuse is X. We know that the legs are 8 and 15. All right, let's see. 8 squared plus 15 squared is 289. Take the square root of both sides. X is 17. So X was the hypotenuse of that triangle. In the circle, that's exactly what we were looking for, pH. So we don't have to really do anything else except write pH equals 17. Start calling my husband Pythagoras. I don't know how he'd like that. All right, number 16. All right, number 16, we're looking for the measure of arc GJ. Forgive me in advance, I have a really hard time saying GJ next to each other. So if I flub it, I'm sorry. GJ, this arc. All right, last class, it's in Monday's Play Posit. We learned that the measure of the arc is equal to the measure of the central angle that makes it. All right, so now going back to this right triangle, how can that right triangle help me? Oh, well, if I can find the measure of this angle, that would be congruent to the measure of the angle over here, and then I would know the measure of the green angle. So let's look at that right triangle again. We know this is 8 and this is 15. And let's find the measure of this angle right here. That would be right here, this little red arc right there. All right, so we're going to use SOHCAHTOA again. Opposite, adjacent, tangent. Yay. So the tangent of the angle is the opposite over the adjacent. Free the angle. Get that y out of there. Okay, well, okay, flip-flop it. 15 go over 8 can go in the parentheses. Y can come out here and be free as long as we use the inverse. Rachel, you're way ahead of me. If you wanted to use that 17, because you know the hypotenuse is 17, you could have used sine or cosine. Yeah, you could have. I chose not to. And the reason why I usually don't do that is because what happens if I made a mistake in number 15 and it wasn't actually 17? Then I'm using the wrong number if I was trying to use that hypotenuse. So I always like to go with the ones that I definitely know for sure. We're not wrong. This is definitely 17. But in the slight chance that we got it wrong, I don't want to be accidentally using the wrong number. Yep, that's a really good question, though. All right, so the tangent inverse is about 61.9. So that means that this angle right here, I'm using my pointer to point at the circle, I think. Why isn't it going behind it? That's weird. Okay, well, I was going to try and use the pointer. You can see it on the bottom, yeah, but not in the triangle. Ooh, should we call this like the Bermuda Triangle? What is going on? That's so weird. Okay, well, we'll try something else. About this like light blue. So that 61.9 is representing this angle right here. I want that whole green angle. So I'm going to say 61.9 times 2, and that will tell me the green angle. So the measure of angle GP, and I've lost what letter that was, J, is equal to 123 point. Okay, now here's, if you take your calculator and you just multiply by 2, it's going to round to 123.9. If you do your 61.9 and just multiply it by 2, you get 123.8. So it depends on if you cleared your calculator or not. I'm okay with either answer. Excuse me. So because the measure of the central angle is 123.8 degrees, that means that the measure of the arc inside of it, GJ, is equal to 123.8 degrees. There's your answer. You can't use the 90 degrees as your angle when using SOHCAHTOA. Yeah, so Rachel, you got 123.9. I saw another question come through. Where did it go? How do you know when you should be using SOHCAHTOA? Okay, so you want to use SOHCAHTOA or trig when you have 2 sides and a missing angle, or you have an angle, a side, and a missing side. You can only use the Pythagorean theorem if all 3 sides are labeled. If one of those sides isn't labeled, like here, number 14, wait, let's see if the pointer works over here. Yeah, in number 14, we were missing this leg, so Pythagorean theorem wouldn't work there. So we had to use SOHCAHTOA. In number 15, all 3 sides were labeled in our right triangle, so we could use Pythagorean theorem. And we didn't know any of these angles, so SOHCAHTOA wouldn't have been helpful. So you're going to use trig or SOHCAHTOA when you have a side, a missing side, and an angle, or you have 2 sides and a missing angle. I hope that answered your question. Yay, good. All right, if you asked a question and I didn't answer it, it's not because I ignoring you, it's just a lot of things came up here. Oh, this was a right triangle. Yeah, it was definitely a right triangle. Let me try. Let's see what happens. Yeah, this was a right triangle. It got kind of buried under my writing, but there it is. Well, a line measures 180, so if it's 90 degrees on one side, it's got to be 90 on the other side. Right? So even if the perpendicular marking is down here on the bottom, this would still have to be 90 here to make it a line. Nice. All right, so there are lots of practice problems on OMHS for you. You're welcome to check them out, practice them, check the key at the end, and you can ask me questions. You have an exit ticket for today. Now I am going to put everything from Unit 10 on Quarter 4. So I'm going to go in and change that. Anything from Unit 10, except for attendance quizzes. So exit tickets, quizzes, tests, anything from Unit 10 will go on Quarter 4. The only thing that you still have to really have done before the end of the quarter are attendance quizzes, because those close within a week. Okay, so get those attendance quizzes done. But everything for Unit 10, other than an attendance quiz, will be on Quarter 4. Your benchmark will open on Monday, and the benchmark covers Unit 6, 7, 8, and 9. So triangle similarity, quadrilaterals and polygons, right triangles and trig, and your transformations, okay? Everybody has to take the benchmark. No one's exempt from that. This isn't a final or a midterm. Everyone takes the benchmark. And then what's going to happen is once the benchmarks are finished, I'm going to download all the data, and I'm going to look at how you did on each individual standard. So I might look and I say, okay, how did Katie do on the similar triangles? Oh, Katie got 5 of 5 questions right on the similar triangles. So I go into the grade book and I say, Katie gets 100. Okay. I'm going to look at each standard that way. So you're not going to see the benchmark in the grade book. It's not going to say benchmark 3 with a grade. But what you might see is you might see your test scores go up because you did better on the benchmark. And I have to pull the data on each standard. So that takes me time because I have to do it by hand for each student for each test. So please be patient with me. And I'm not going to put in lower grades. I wouldn't do that. Nope. I don't replace it with a lower grade, just a higher one. I want your grades to go up too, believe it or not. I really do. I'm not going to lower your grades, promise. Okay. So hopefully that helps motivate you to want to do better on the benchmark than you did on those tests. Think of the benchmark as almost a test retake. Now here's the one stipulation though. I don't replace missing tests. So if you haven't taken a test and you have a 0 sitting in there, I'm not replacing zeros. You gotta try it at least the first time, okay? So everything from unit 6, 7, 8, and 9 will close on Friday the 11th, and I can't reopen it. So you wanna make sure that you have all of your missing stuff done by the 11th. Check out your grades on OMHS, see if there's anything missing. Remember, you get 2 attempts on exit tickets and quizzes. So if you have a low exit ticket, you have a low quiz, try to retake it because you probably have a second attempt on it. Not right now, Moheen. So I don't know how many questions the benchmark is. I don't memorize that stuff. So it's decent. Trust me, I didn't make it like crazy long. I wouldn't do that. And then of course, the honors one is going to be a little bit different than the regular one. There will be some semester 1 content on it. Yeah, there will be like maybe 1 or 2 questions from semester 1. But really, you're using semester 1 content right now, right? Like we use vertical angles all the time. We use linear pairs all the time. We just used the biconditional today, right? So stuff that you've learned in semester 1, you're still using it right now. Okay, so if you focus on semester 2, you'll be fine. Those are the ones that I'm replacing. I'm not going to go back into semester 1 and be replacing those test scores, just the quarter 3 stuff. Sybil, can you email me that question? Yes, okay, and then the backstory of the cat, right? All right, I think I answered all of, excuse me. I think I answered all the questions from the benchmark. If you're asking me something personal, like what can I do to make my grade higher, send me an email and I will look into it for you and send you a response. Okay, I'm going to stop recording, but then I will give you the backstory of my cat.